Seems like we are live. Okay, I'm just looking at the bit rates. TX is fine, I guess. It would be around 7 kilobytes, which is pretty good, I guess. Right. So earlier this was complaining. Let me just let's just see. Wait a minute. I'll do some quick testing. The text is not bad. Well, it is bad. Why does this look so bad, bro? Well, the initial this time around 1 minute. I guess I'll learn later. So yesterday was here like explaining these things. Let's continue from here. So this buffer thing is, what is this buffer thing? So if I look at my code, then will make sense a lot better. This is nothing but a type, right? For the time being, and this is nothing but a variable name. What is the type of this variable? Let's just forget about that. So with that being said, this is some normal variables, let's just say, and it's its address, and there will be some value in this, which I don't know what. But as per this, I would say that a, the type of the value that this variable contains is pointer to a pointer. It's a double pointer. So let's start here. Okay, so this is some variable v, right? And so this is some variable v, and it has some address, let's just say 200. Cool. And they're going to be um, it's a pointer to it's a pointer to unsigned 8. Basically, buffer contains a value which is an address of some variable that also contains an address. This is, so double pointer means both of them contain some address. That is all, right? So this contains some address. This contains some address of what? Let's say it's a byte. Then what do we have? So if I say like, if this is a single byte of type, let's just say some value 8. This is some variable. This is some normal value, and it has some address like say 300. Now, if I say that it's a pointer, so it will contain some address, and it contains address of this. So I can say that this points to this, or this, whatever. Right. Then what is the type of this? So type of v becomes, it's a pointer to int, pointer to 8-bit. Right, that is all. I mean, is it? V is a pointer to this. What is the type of v? For the time being, if I'm saying, let's just say uint arr, this essentially means this, right? In a hindsight, let's just say, and this would say uint v contains address of rr. That would say that v is a pointer to int. V is a pointer to int. Arr is an integer, so unsigned, yeah. Now what is, if I say something like, let's just say, and buffer contains address of v, that means 0x200. This would if buffer contains array, this makes buffer, the type of buffer, it will be the type of value that it points. So it points a value of type this. So it points a value of type this, right? Sorry, f points a value of type this. That would make it if it contains a value of type this, but this is also a pointer. Address of v. Makes sense. It contains a value whose type is an address. Buffer contains a value whose type is, okay, or let's just start with very simple thing like here. So arr contains an integer. So the type of arr is uint 8-bit integer, right? Now if a pointer, now let's forget pointer. Now if I store this address in some variable, then type of this variable will become uint star. I'm not calling this pointer because that term is polluted and doesn't convey something. Not polluted, but you get the point. We just lose track whenever I use pointers, because pointer like what. So this is a arr value variable. It has a value 8, which is of type this uint 8. Now I have another variable v, which contains this value, and it is of type uint 8 star. Makes sense. Now I have another variable buff which contains a value, this, which is an address, to this, of type this. It's a pointer to int, so it's a pointer to a pointer. So buffer is a pointer to a pointer, which is a pointer to an unsigned integer 8, which is a pointer to an int. Make sense or not? So if I, so in code, in code basis, I'll be dealing with this text, not these diagrams. So let's just try to make sense by this. So buffer is a variable that points to a pointer which points to an integer, which points to this. So buffer is a pointer which buffer points to this, which points to unsigned integer 8-bit. I think I'm comfortable with this, right? So double pointer means it just contains a value. So buffer contains a value which is an address of another variable which also contains an address. So to get to the uh, to get to the to get to the actual data, I'll have to jump two addresses. So first will this, then will this. Right. So now this part is sorted. Now what is this? It's a double dereferencing. So the first dereference means okay, so dereference essentially means, so let's just deal with first dereference at a time. So this is first dereference, like, yeah. So first dereference means give me the value which is at this address. So buffer, this would say, means, this means give me a value which is at address buffer. Hence it is an address of, no, value of, it's a value of operator, value of this. So let's just talk about in terms of normal variables. When I say like if I equals to 1 and I say printf give me value of I, what do you say? I simply say this, that I have a variable I which contains a value 1. It has some address, let's just say 67 something. When I say simply that give me the value of I, that means give me the value that is inside this box. Makes sense? So now similarly, when I say buff or variable name, that simply means give me this 200. So I can say give me this 200. But when I put star in front of it, that means give me the value at this address. So I go to this address, which is this, which is nothing but this box. So I say 300. So my star buff will be nothing but 300, which is nothing but value of v. So the whole thing, I can say that buffer is nothing but v. Like dereferencing the buffer nothing is equals to like v, because v also has this 300 and the value at this address, which is this, also has the value 300. So now I dereference one more time. It means give me the value which is at this address. So I go to this address and I bring it. So hence this becomes this will be equals to this, which is nothing but 8. Understood? So we are doing nothing but this buffer says that I have some address of a variable which has an address to in unsigned 8-bit type value. So you just access that value. That's why a value. Now what is this? Now if I so if I come this and I do something like what is this? One single star. So if I say like, what does this mean? So I can replace this with v, right? That means v plus plus. And what is the value of v? So if I come here and say 300 plus plus, or I can say this means 300 plus 1. But here's the catch, because this is a pointer arithmetic. So in this case, this definitely will equals to 301. But in case it was not a unsigned 8-bit, then this one would have been something like, the compiler would do that actually. We would still be adding 1, we would still be doing this plus plus, but the compiler would add some other things, actually multiply something. So if I say that, let's just say this is not my 8-bit, it is 32-bit. In this case, the compiler will do something like this, multiply by 4, because it's a 4-byte thing, like it's a 4-byte. So in that case, the address would move by 4. But since our case, the byte is 1, so this corresponds to 301. So now if you see that when I do this, that means I'm moving my variable, which is a pointer to this integer thing, I'm moving it onto the next memory address. So I'm saying that, that there are another thing which is exactly like this. It has some value 4, let's just say 3, 2, right? And it has some address 0x 301, 302. You get the point. I'm just doing this for the sake of completeness. Right. So essentially, by this, by doing this, I said that I access the underlying pointer, a simple one direction pointer or whatever the official term is, means I access the v and I change the value of v, means I plus plus 1. Now v has value of 301. So I say that that means this guy points to here. I'm just moving pointers. So it's a very fancy way to move pointers. He's good, man. It just it. Cool. We understood that. Yeah, so I was saying that everyone should learn C, and by C I mean memory. Memory is super important. Like, you are dealing with computers, no matter your domain, no matter if you're a web programmer or whatever you're doing, you're dealing with memory, bro. Learn about it. Excellent. Cool. So this is out of the picture, and I did implement it yesterday, but my stream got destroyed because of the lack of money. Next thing is, so it what this essentially that is something that is happening here is unpacking a byte. So it's some address. So buffer contains some address which um, buffer contains an address of some variable that also contain an address to an array. Got my point? So buffer contains an address of some variable which also contains an address of some array. Hence the double pointer. Means how many jumps you have to make to get to the real data. Because this is not a real data, it's just a direction to that. Like, where in the memory I have to go. So pointer tells you that. So pointer says go at this location. You go at that location, you find this value. You say no, this is not the real value, because compiler can tell you, because it has a type of person. It is a pointer type. It is not a data type. You go here. You find that this is an address. So you go to this address. You say okay, now I have the value. So to access the real data, how many jumps you have to make? That is the level of indirection here. So we have two level of indirection. So to get to the real data, I have to jump twice. Hence the two jumps. because this is a head pointer essentially. Means it is something like this. When you have a linked list, let's just say talk about linked lists. So let's just say you have this. So you have some linked list, right? What you do is you have some a pointer basically, and you call this head, which is nothing but a pointer to your uh, the location where you do insertion or deletion or whatever, right? Let's just say it's a single ended linked list, and you have a head which points to the location where you can insert data, right? First out, something like that, whatever that is. So similarly, this is nothing but a h head, so we can essentially call it head. It contains the address of from where I have to gather the from where I have to put or the way from where I have to get the data. Or in some cases, I can use it in whatever way. I can use it to get the data, or I can use it to modify that particular location. So it just points to a single location. It just happens to be an array, which is contiguous in memory, of course. So I can use that property to jump to the forward or backward. Right. So that's very, very good. So it's not it's not simply an head like in case of linked list, just a similar concept. So if I'm so so the reason I have buffer here, not I'm not just passing this. So what I'm saying is that why I cannot pass a single pointer here? Why I'm passing? Why I have to go to a level of indirection? Why I can't do this? Like I can simply pass in head. Of course you can. Maybe there's some reason behind this, because um, maybe this is somewhat intrinsic in the packet that I receive. Means maybe let's just say this is a surety that whatever packet I receive will contain a pointer which will actually point to the actual data, which is an array of some memory location which is contiguous, could be heap, could be whatever, right? So maybe this is for sure is there, and as an outside entity, the API calls, or maybe if helper functions, whatever, as an outside entity, I only have access to this first thing, right? I cannot directly access this. So maybe that is the reason we have to use two level of indirection, and this is how pointers are. So the double stars. I think it is clear now, right? At least it is clear to me. Hmm. Next thing is I unpacks you 2 bytes. So this is my buffer. Actually, I should call it head, but whatever. Okay, which will give me 2 bytes in this case. Similarly, I'll access 2 bytes, which is a value. No, and I cannot access this because it's more than 1 byte. So what I'll do is memcpy memcopy. I'll memcopy from the destination. So the destination is my address of value, and my source is the address from where I'll pick the value. So if we go back to the example, now let's just say let's take this particular pointer. So the way memcopy works, memcpy, it says I want to store the value at this destination, but I want the address of source and the size. Now, what is the source? Source says that basically source means you have to have this has to be an address from where the copy will happen, right? And this is the number of bytes that will get copy into here. So how do I access this address using what I have only this buffer. So I have to access this location 301. How do I access this? Using buffer. So where is 301? 301 is here, and my buffer contains this address, which is this. So if I say something like this, if I write something like this, that give me the value at the address that buffer contains. So my buffer contains the address 200. Now I'm saying give me the value at address 200. Means I'm dereferencing. Means give me the value of v. Let's just call it v. Right. I'm just simply saying give me the value of v. Like this is right. But how do I access the value of v using only buffers? Well, the relationship between those two are this. Simply I just dereference the buffer. So I can simply say that if I do this, that means dereference the buffer will give me this value, which is nothing but an address to the element that I want. So I'll go it at this address 301 and I'll copy a single byte or whatever bytes I need. In this case, I'm copying 2 bytes. So I'll go at this address which corresponds to this it's at some value v, and I'm passing the address 301. From there I copy 2 bytes, right? Something like this. It will become something like this. And this is another function. It seems like another function call, but you get the point. So maybe I should just, so what this does is this will do things like it will give me 2 bytes, which is 3,3, like these two. Cool. So this is what should be happening here. Some value, yeah, buffer, and the size because I want 2 bytes into this. And then I have to increment the v. See, I accessed these two values. Now uh, I'll update this pointer to point to here. And how do I do that? Well, I have to move. I have to like let's just say what does it mean by when I say I have to move this arrow from here to here? Now, what does this mean? Well, this means but first we have to ask what does it mean for an arrow to point? That means it contains an address. And to move an arrow means I have to increment the address or decrement the address, whatever. In this case, I'll have to put this value into here, which is 3, because I've accessed these two values in this iteration, and the previous iteration I accessed the 8. Now, how do I increment v using only buffer? You got it. There is the relation. I simply say I dereference buffer, which would give me the value that v has, which is 300. This would give me 301, which was previously, which because it was here. And I say, and if I say plus plus, oh, not plus plus, but I'm saying plus equals to 2 because I access 2 bytes. That would give me this plus 2, means 0x303. Hence, so I just simply dereference this and increment this by 2. By dereferencing it, I get the I am by dereferencing buffer, I'm actually modifying v here. And now this endianness, right? So I'm converting. So whatever the order host has, I have to convert. So sorry, wait. This is coming from network. So whatever order the host has, I have to convert my network byte into the host address, a host order, which could be big endian or little endian. Network endianness is always big endian. So it's just endianness thing. Cool. So let's just type this. Let's just do this. So I have to copy 2 bytes from some source location into this well variable, which we said like this, right? And the size of well, and now I'll increment the now I have to increment the v, remember. So how do I do that? I do this by buff. I say that just be little more descriptive, plus equals to size of val. So I incremented this by that much, and now I'll return and to network to host. Long short, it's a short, network to host short. I give 2 bytes, which is a well. Cool. Similarly, I'm unpacking 32 bit. Size of well, right? This is it has to be like this, right? Their value. Network to host long जाएगा भाई. Next is I unpack bytes. What do you mean by that? Unpack bytes. Seems good. So this is the okay. So this is the location where I'm unpacking it, right? Because the const says so. It's the constant to data. So it says that the I cannot change the data, but I can move pointers. It's a constant data, not the constant pointer. And this I can change data as well as pointer. So this essentially says that it's the destination, this is the source, this is the length. Unpack bytes. So I'm copying this many bytes from this location into this location. Then I say in the end, but wait, I see a bug here. The bug is why can't I use str and cpy sn printf? Sorry, why can't I use sn printf? But why do I use that? I'm just simply copying it, so it shouldn't call a library function. That's heavy. The bug I'm seeing here, I could be wrong, is that you pass in length in here, so it copies this many bytes into this, and this length is the number of. Okay, so it's up to the caller, but okay, so I'll have to say my thoughts. I cannot convey what I'm thinking on stream, right? Let's just say the caller passed in like 2 bytes. Sorry, 2 is already covered, 4 is already covered. Let's just say caller says that he wants to copy 5 bytes of data from this into this. Now what this will do, it will copy 5 bytes, means it will start from 0 to 4. It will go from 0 to 4. 5 bytes completely done. Now you are adding at location 5 this value. So it already copied data from location from location 0 to 4. So the 0 to 4 is already filled, gets filled here. Now you say at fifth position you put null. But what if the size of this is exactly this much, and this is exactly this is conveying here? You getting my point? Let's just draw this something like this. Right, so let's just say this is your str. Right, so this is your str. You say the size is 5, let's just say, and which is 1 2 3 4 5. Right, now you are saying that you want to store some data in here. Just delete them because I have no data yet. Right, so want to store 5 bytes from this buffer into this location. All right, so the mem copy will copy 5 bytes from buffer into this str. So the str will 0 1 2 3 4. Cool. So str will get 5 bytes. So all of these are filled, like 0 to 4, 5 bytes are filled. Now you are saying that at fifth position you want to put this null. But bro, there is no fifth, nothing is there. I mean, there would be some memory and you would be putting null at some undefined, like unauthorized memory. Like that is clearly not falls under this range. And then you say that you point buffer to this. Okay, so this is fine. Some buffer which is it could be like bytes, stream of bytes, so it could be more than 5 bytes. Like this is not really the concern here. My concern is this: you should put this at len -1. See, see. So I can say one thing that now I'm thinking whether should I fix this or not, because I mean it is a bug. You are writing at some memory location which you clearly did not account for. This len, it just says that what is the size of this thing is, that it points to, that whatever location it points to, what is the length of that location, or whatever the data structure is. It just says that. And if I'm making it a string, nah, I definitely should put -1 in here, because let's just say it copies this much bytes, or maybe it's a helper function and the corresponding implementations are network order and byte order, packing and unpacking. So what this might be doing is, yeah, I'll just implement it as it is, because I don't know the bigger picture here, which is the whole MQTT implementation. So like it could be something that I'm missing, but if I get some bug, then I know where to look. Right, so unpack bytes. So how do we gonna do this, boys? So unpacking bytes means you return a pointer to string. So I return this and I unpack bytes. Bytes, right? So the first thing is the buffer from where I wanna, and the oh wait, what is this length signifies? This length says from this read this many bytes. So and writing in here, so writing is where the concern is. So this, yes, this is the length of this. So I'll say that as is size tlen and unt it, and I'll, the destination is str and the source is definitely buffer, right? Yeah, and this many bytes I want to write. Now I'll move the v, the head, this many bytes, which is essentially uh, plus equals to length bytes. But before that I should put null into here, which is nothing but 0, and now I move that head this many bytes forward. Do I changing some order or not? This is a simple string, so I'll just return this string. Next is I'm returning 16-bit. Okay, so you say unpack 16-bit from this buffer, you allocate len plus 1, which is your destination, and now you unpack bytes. See, the during the part of allocation, memory allocation, it took care of the 1 byte that was missing or that is required for null character. Let's say 5 bytes, it wants to read 5 bytes, then this would be 6 bytes. And now I say I want to read 5 bytes into this destination from this. So the destination will, okay, already have, see, okay, not the bug. Okay, the way, like I said, the way it is handling this is unpack 16, which returns a pointer, no, which returns a 16-bit. From where do I wanna buffer, and into which buffer, right? What is the destination? Why is it a double pointer? I have no idea. So the length is y length. You say unpack 16-bit. And why is it a length? Unpack string 16 means when I call this, I'm sure that the very first byte that is being pointed by this buffer is going to be length, 2-byte length. I think maybe it will make sense later. Unpack u16 from this buffer. Where do I wanna store this pointer into the location that is being, it's saying something like this, that I have this buffer, let's just say that this is the buffer, and move the pointer back in here. It is saying something like this, unpack 2 bytes, and that would essentially move this pointer here. I'm not modifying the address for now, right? So this will move this pointer here, and you say that now you memory allocate, now you allocate some memory. Let's just say you allocated this much memory, and you said that the starting address of this memory is going to be stored into this DST thing. So this DST is, this is some variable which is contains a pointer to another one, which is some variable that I don't know. You essentially say that some destination which will means this is a double pointer, so it contains an address of some other pointer, means it basically points to some pointer which points to the actual allocated memory. So now you say that the allocated memory gets stored in this. So I just say 0x, it has some value 500. This is the starting address of this. So now you are essentially saying that dereferencing that will means dereferencing DST means dereference means go to at this location, which is this, and at this location you store the allocated address, allocated memories address. So basically in function I have been given access to this DST in that function call, and I'm using this DST to go to the head of some and I'm storing like this heap allocated memory at this location. Now I'm saying that unpack bytes from this buffer into this unpack bytes from this buffer. So sum buffer, this is my sum buffer. It is sum buffer, you would say it is sum buffer, and now you are saying from this buffer get this many bytes and store it into the destination. That means from this buffer I'll read this many bytes. Dereferencing this will give me this value, which means at this address, which is nothing but this 500, means at this location. So essentially I'm taking data from here and putting it in here. How many bytes? The length bytes, len bytes. So this is fine. Okay, so I know who owns the memory now. You remember this was the function, this was the argument or the parameter that passed into the unpack function. This is passed into here. So the ownership will be of the entity whoever passes me this address. So I could have used this directly, but I don't know if this is how the protocol works. So maybe the protocol constrains us to use double pointers. So whoever passes me this pointer owns this whole thing. And how much this length is. This buffer that the initial 2 bytes of this buffer, see, the initial 2 bytes of this buffer contains the information about how big this mallogged memory is going to be. So if this is, let's just say, 50 bytes, then my size of this is going to be 50 plus 1, 1 for the null. Right, so this is how it is. So the initial 2 bytes are the length of this thing, and now it's sorted. Cool, move forward. So this buffer contains the, how many bytes do I wanna allocate? It is length plus 1, and now what? Now I have the memory area where I want to copy some n bytes. Which is, when I unpack bytes, this many bytes into this string, is, does the value inside this variable gets modified, means the address that it contains. No, at this alien offset, means at this alien position I store this, but I not necessarily modify the address. Like I don't change the value that str contains. Str contains some address, and I'm just storing this many bytes starting from this address, from this buffer, and at the end I store null byte, and I'm moving the buffer, so I'm moving this, not this. That means my DST will not move, but my buffer will, because I have consumed this many bytes from this. Oh, I can use this to move, like in the event bus that I implemented. That is a simple copy. Everything is gets copied, pass by copy. So I'm not using references or pointers to pass values. In that event bus, I was initially having thoughts like who is going to be the owner of the events that the event bus receives. And I can say some simple something like this, like uh, whoever uses the bytes just moves the pointer forward. So essentially means whoever accesses the buffer consumes the bytes. Cool. DST is unpack bytes. How many bytes do I want to unpack from where? Okay, so the moment when I unpacked 2 bytes at this line, then I modified the buffer, means I moved the pointer forward 2 bytes. Now I want to unpack bytes, which is from this buffer, this many bytes, and into a location which is tst. All right. Yeah. So in this case, now I'll move buffer by this many bytes. And when that happens, I'll return 16-bit. Are you converting some host thing or not? No, I'll return the length. I have unpacked this many bytes. Cool. Now I have to write data, which we will pick tomorrow. Right. Okay. We'll continue from right tomorrow. See ya, boys. Good night.